Hi all, good afternoon to everyone. Hope you have gone through the yesterday session. Have you evaluated the series? Have any doubts in the yesterday session? I have given 4 exercises. Have you all completed that? Prasanna, Pooja, Harita, Rishikant, Suveta. Have you all completed the exercises? No responses from your side. Or have any doubts in the last session?
No, sir.
No, sir.
Okay. Okay, I give you the time, right? Try to complete the exercises and upload it in Drive. In this session, we focus on first nested looping statements. Nested looping statements. We have seen the for loop. For loop takes this general form for initialization, then condition test, then variable modification or update for the part of for. This is for loop statements. How for loop works? First, when the control enters into the for loop, initialization is done only one time. This is the first part to be executed. Once the initialization is over, then control goes to check the conditional part. This is number 2. If the condition results in true, then third part, control goes to execute these statements. Then fourth one, a variable update. This part will get executed. Then after the updating of variable, condition is tested again. If the condition results in true, control goes to execute the part of for loop statements. Suppose here statement X is available. When the condition is false, control comes out of for block. It executes the next statement following the closing curly brace, that is this statement, in the sequential order. This is the execution of for loop. We can place a for loop inside another for loop. Then that is said to be a nested loop. For example, have a look into this block of code for assuming that the variables are declared I is equal to 1, I less than or equal to 10, I plus plus. Here we are printing the value of I. I write a statement print percentage d comma I. For each value of I, the printf statement prints its value. Then inside this for, we have another for, assuming that the variables are declared for j is equal to 1, j less than or equal to 5, j plus plus. Inside this inner part, let us have a statement printf percentage d comma I plus j. Outer closing curly brace here given. This is to be the inner loop. This is the inner loop. This part, right? This defines the outer part. So one part or inner part is controlled through the outer part loop. So how many times the inner part gets executed, this depends upon the conditional part defined in the outer part block. In this case, see the flow of execution. Outer part starts at I is equal to 1. So here I write the trace when I is equal to 1. Condition to be tested is I less than or equal to n. 1 less than or equal to 10. Condition is true. So first it prints the value of I. The value of I 1 is printed. Then control enters into the inner part. There another variable j is defined. J ranges from 1 to 5. So carefully understand, when I is equal to 1, 1 is printed. Then the variable j takes a range j is equal to 1, j less than or equal to 5. That means j takes the possible values 1, 2, 3, 4, 5. That means when j is equal to 1, when j is equal to 1, 1 less than or equal to 5 condition is true. Printf percentage d I plus j, current I is 1, 1 plus j, j is 1, 1 plus 1 is equal to 2 is printed. Then the next value of j is 2, j plus plus, right? Upon the execution of j plus plus, j becomes 2. Then j less than or equal to 5, 2 less than or equal to 5, the condition is true. In this case, we need to print the value of I plus j. What is current I? Current I is 1, j is 2, 1 plus 2 is equal to 3 is printed. Then when j is equal to 3, 3 less than or equal to 5, condition is true. Current I remains 1, j becomes 3, 1 plus 3 is equal to 4. J is equal to 4, 4 less than or equal to 5, 1 plus 4 is equal to 5 is printed. Next when j becomes 5, 5 less than or equal to 5, condition is true. 1 plus 5 is equal to 6 is printed. Then when j becomes 6, next value of j is 6. Checking the condition 6 less than or equal to 5, here this condition becomes false. So control comes out of this inner part. After this inner part, here assuming that no statements are given, then control goes to increment the value of I by 1. So next value of I is 2 after I plus plus. This implies next value of I is 2. When I is equal to 2, condition to be tested is I less than or equal to n. 2 less than or equal to 10. condition is true. In this case, we need to print the value of I first. Print a percentage di, prints I, current I 2 is printed. Then upon the execution of this inner for loop, what happens? J ranges from 1 to 5. That means similar to the previous execution, J is equal to 1 to 5. Here J is equal to 1, 2, 3, 4, 5. These are the possible values of J to be considered in the inner for loop. For each value of J, we are printing the value I plus J. Suppose J is equal to 1. I plus J means current I is 2. 2 plus 1, 3 is printed. J is equal to 2. I plus J, I is 2. 2 plus 2, 4 is printed. J is equal to 3. I plus J, 2 plus 3, 5. J is equal to 4. I plus J, 2 plus 4, 6. J is equal to 5. I plus J, 2 plus 5, 7 is printed. Next, J becomes 6. 6 less than or equal to 5 in the inner for loop. J less than or equal to 5. Condition is false. So control comes out of inner for loop. Then the next statement to be executed is I plus plus. Next I becomes 3. So when I becomes 3, the 3 is printed. J ranges from 1, 2, 3, 4, 5. I plus J is printed. This way, the inner for loop is controlled by the outer for loop. Outer for loop is executing for 10 times for each I is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Similarly, when I reaches 10, final value of I, 10 less than or equal to 10, condition is true, then the value of I, 10 is printed. There also J ranges from 1, 2, 3, 4, 5. Printf statement, for example, as we are given in I plus J, prints the current value of I plus J. J is equal to 1. 10 plus 1, 11. Then 12, 13, 14, 15 is printed. Then J becomes 6. Control comes out of this inner part. I will be incremented by 1. I plus plus. What happens? I becomes 11. Entry condition into the for loop is 11 less than or equal to 10. Condition is false. Then only control comes out of the outer part and it executes this statement. Say S1, then S2 in the sequential order. This is to be nested for loop. We have nested the for loop twice. Similarly, we can nest the for loop thrice. For example, one takes for I is equal to 1, I less than or equal to 5, I plus plus. Another for loop for J is equal to 1, J less than or equal to 5, J plus plus. Inside this another for loop, assuming that the variables are declared. J is equal to 1, J less than or equal to 5, J less than or equal to 5, K plus plus. For example, we have given some initialization and conditional testing. K plus plus. Printf percentage t, percentage t, percentage t, I comma j comma k, closing curly brace for this first inner part, then second inner part, then third right part, outer part. This is outer part having two inner part loop statements. This is first inner part. This is controlled by this another inner part. The second inner part, this is controlled by the outer part statement. So just to think of how will be the flow of execution when I is equal to 1, j starts at 1, j less than or equal to 5. Previously here 1 less than or equal to 5 condition is true. So j starts from 1 to 5. Then I is equal to 1, j is equal to 1. K ranges from 1 to 5 because k starts at 1 less than or equal to 5. So I is equal to 1, then j is equal to 1. Printf write these values I, j, k prints is1, js1, ks1. Next, assuming that we are given in a new line, I is 1, j is 1, k becomes 2. I is 1, j is 1, k becomes 3. I1, j1, k4. I1, j1, k5. When k becomes 6, 6 less than or equal to 5, condition is false. So next it goes to execute the value of j by 1, incrementing j by 1. J becomes 2. Still I is 1, j is 1, j is 2, then k varies from 1 to 5. So 1 to 1, 1 to 2, 1 to 3, 1 to 4, 1 to 5. K is j is incremented by 1. J becomes 2. Next, when j becomes 3, we can expect the message 131, 132, etc. 135, 141, 142, 145, 151, 152, 155. This is the complete execution of I is equal to 1. Then when I becomes 2, 2 less than or equal to 5 is true. This inner for loop controls another inner for loop, this one. So based on the conditional test, number of times this inner for loop is going to be controlled. This is to be nested for loop statements. We can place one for loop inside another for loop. Have any doubts in this nested for loop?
No, sir.
Have okay. We can use the nested for loop, right? You can ask, right, where or when can we use this kind of nested for loop? For example, to add two matrices, to multiply two matrices, to subtract two matrices, or to print the results, right, in a form of right 1, 1, 2, 2, 1, 2, 3, something in some order or in some patterns. We can use nested for loop statements. Like nested for, as we have seen earlier, while statement can also be nested. What is the simplest form of while syntax? While condition part of while block statements, and this is the next statement following the closing curly. Then the condition is true. First condition is tested. If it is true, this while block statements are executed, if the condition is false, control comes out of this while block opening and closing curly braces so that it executes the next statement sequentially. This is the syntax of while loop that we have discussed. Now we can place a while statement inside another while statement like a for. Nested while is also supported. For example, while I write C1 to have a condition 1, have some statements, then while condition 2, this is a second while loop, have some statements, closing curly brace, then following this you can have some statements. Clearly this while C2 opening and closing curly brace, this acts as the inner while loop. While C1 this opening and closing curly brace, inside this, right, how we have stated in the syntax, these are some executable statements. These executable statements may also have a while block like this. So this opening and closing curly brace defines the scope of our outer while statement, outer while loop. How the nested while gets executed. Nested while is executing, right, in the sequential order. Once the control enters into the condition execution C1, it checks if C1 is true. Any non-zero value is said to be a true in C language and 0 is said to be the false value in the C language. So when the condition is true, then the true block statements are executed. Suppose here after the execution of these two statements, then control enters into this while block statement C. In case C2 condition is true, assuming these three while statements are executed in the inner while. As long as C2 remains true, these three while inner while statements are executed. Once the inner while condition becomes false, control comes out of this inner while and it executes these sequential statements. After the execution of these three sequential statements, then control goes to test the condition C1 again. If C1, as long as our C1 remains true, then the while block statements are executed in the sequential order, including this inner while. At any stage, if at one stage the condition C1, then C1 becomes false, control comes out of the outer while and it executes the statements here onwards sequentially. This is the logic of a nested while statement. Understand? Have any doubt in the execution of nested while? Likewise, we have seen a do while condition. Do while do set of statements finally specifying the condition while some condition C. This is the do while syntax. Without checking the condition, part of do while statements are executed once, then control is going to test this conditional part. As long as the condition remains true, these statements are executed sequentially. When the condition is false, control comes out of this do while block. It executes the next statement following this while statement in the sequential order. In the same way, do while can also be nested. There is no doubt in that. For example, do having some statements opening curly braces. Okay, this is opening curly braces. Then after some statements, I put do opening curly brace, closing curly brace, while inner condition, for example, C1 semicolon, then some statements outer closing curly brace, while condition C2 semicolon. This is clearly the inner do while, inner block, inner loop, we can say inner loop. This opening and this closing curly brace defines the outer loop. As usual, control goes to execute this outer do while without checking this condition C2. So these statements are executed sequentially. Once it encounters the inner loop, the normal do while rule is applied. So here, without checking the condition, do while statements are executed. Then the condition is tested C1. If C1 remains true, do while statements are executed in the sequential order. Then C1 becomes false. Control comes out of this inner do while and it executes the statements in the sequential order. Then it checks the condition in C2. C2 is true means then outer do while statements are executed. When C2 becomes false, when C2 becomes false, control comes out of outer do while. It executes these statements in the sequential order. So for can be nested, while can be nested, do while can also be nested. We can also mix right these looping statements. Inside the for, we can put another while, or inside the for, we can use do while, or inside the while statement, we can use for, or in the do while statement, right? We can use a while statement or for, right? So whatever is, we can mix these looping statements are also. At any stage, if you want to come out of the inner loop, logically use break statement. The break statement breaks the control from the inner loop. The syntax of break statement is break the semicolon. For example, for I is equal to 1, I less than or equal to 10, I plus plus. Having some statements here, path j is equal to 1, j less than or equal to 10, j plus this. Here have some statements. Suppose if we have if I plus j is greater than 5, then having a break semicolon, what happens if the condition is true here? Break statement forces the control to come out of this inner part. This is the inner part. Break always exits from this inner loop. Since this break is introduced within this opening and closing curly brace, when I plus j is greater than 5, suppose I is 1, j is 1, right? 1 plus 1, 2 greater than 5 parts. Then 1 plus 2, 1 plus 3, 1 plus 4, 5 greater than 5, 1 plus 5, 6. When I is equal to 1, j is equal to 5, I plus j is 6, 6 greater than 5, condition is true. Then this break exits from this inner loop so that the subsequent values of j 6, 7, 8, 9, 10 will be skipped and the control comes out of this place and goes to execute these sequential statements. Then it has to increment the value of I by 1. In case in outer part here, assuming that if you have introduced a break, or here, right, as a part of outer part, if you introduce the break, then that break exits from the corresponding loop. Since, for example, here if you introduce the break, this break is associated for this outer part. So execution of that break forces the control to come out of that outer block. That means to come out of that outer part. This way, break rate may also be introduced inside the while loop or do while loop. Have any doubts in this? Have any doubts in nested looping statements?
No, sir.
Okay. Now let us solve problems based on this nested looping. Please take this problem. Next exercise. First, let us solve one problem. Then this can be controlled through the outer part, right? I tell you. First, to check if the given here is given here is leaf or not. This is the problem. We need to check if the given year is leaf or not. So to check if the given year is leaf or not, we need to check for two things. If year mod for this is equal to 0, then this is leaf. This is the case for non-century years. For example, 2024. 2024 is divisible by 4, so this is a leap year. Second, 1700 What about 1700? It is divisible by 4. Last two digits 00.
Yes, sir, it will be true. Zero, sir.
Yeah, but this is not a leap year because this is a century year. Century years are leap years if and only if it should be divisible by 400. Year mod 400 is equal to 0. Then this is the condition for century years. So clearly 1700 is not a leap year. If we say 2400, 2400 is divisible by 400 because this is a century year. So this is clearly. Now we can easily check a condition using the relational operator, logical operator, right, and or not, less than or equal to relational operators, right? So forming the compound condition, we can easily bring this into a single expression. If year mod 4 is equal to 0 and what is this double ampersand? Double ampersand.
And
What?
operator.
Yeah, and operator. Very good. Logical and. Year mod 4 is equal to 0 and I am checking year mod 100. This should not be equal to 0. This is not equal to operator. Year mod 4 is equal to 0 and year mod 100 not equal to 0. Say 2024. 2024 mod 4 is 0 and this should not be a century year. So for checking if it is a century year, I am checking year mod 100. This should not be equal to 0. 2024 mod 100, that is 24. 24 not equal to 0. So if year mod 4 is equal to 0 and year mod 100 not equal to 0, this is one condition for non-century years. Next I use this operator. What is this operator? 5 symbol. Twice I hit 5.
Logical or.
Yeah, logical or. Either this condition is true or year mod 400 is equal year, year, year mod 400 is equal to 0. So two conditions are introduced. This is one logical condition put in parentheses, another one are. So if any of these two conditions are true, I use one more opening parenthesis and close the parenthesis here. If any of these two conditions are true, what are the conditions? Condition 1, this is the compound condition. If the condition 1 is true or logical or, condition 2 is true, then then the given year is a leap year, else the given year is not a leap one. Understand? Understand how we have formulated the conditional statement in the if statement. So to check this, we can write a program. For example, I write a program hash include svdio.h into main Here, checking the given year is leap or not. Into year, printf slash n, please enter the year, and percentage d ampersand year. Then checking the condition if year mod 4 is equal to 0 and year mod 100 not equal to 0, or year mod 400 is equal to 0. Printf percentage is, what is percentage d? The variable year. Else printf slash n percentage d is non-leaf, comma year. Let us close the main function. Return to 0. Let us check the code file CP31 file save CP32 F9 control F9, enter the year 1700. 1700 is non-leaf. Then control F9, enter the year 2400. 2400 is leaf. Control F9, 2404. 2404 is leaf. Understand this example. Here, logical AND operation, then logical OR operation. Here I put, to avoid the confusion, this is the condition 1. Of course, the condition 1 has been put in the parenthesis, not necessarily to put in parenthesis, because this is logical AND operator, this is logical OR operator. Logical AND takes first preference. So this condition is tested first. Then or if the condition results in false, right? A control comes out of this if statement. Or this is one condition, this is another condition. If both conditions are right, or if any one condition is false, this one, if this is false, first condition is false, then second one, if it is true, false or true, result is true. Or the first one is true, second one is false, true or false, results in a true. When both conditions are false, ultimately control comes out of this if block, else statement will get executed. Understand? Any doubt in this example? Any doubt? Okay, I make the next example. Edit, copy, CP32, Daily phase CP33. First, in this example, let us see the use of right. First, for loop. Check or the problem is print the leaf years in the interval say 1 comma 2500 are including the interval closed interval 1 comma 2500. This is the problem. We have these conditions as usual. The years range to be checked is inclusion of 1 and 2500. So in this example, the range can be obtained. So range right, if possible, we can specify two variables. Say into start comma end. Enter the start range or starting year. Scanf percentage d here start. Then printf slash n enter the ending year. Scanf percentage d ampersand. Say the ending year is stored in a variable end. Start and end are obtained through the keyboard. For example, we can input start is equal to 1, end is equal to 2500. Let's try to find right or print only the leap years in 1 comma 2500. That stage here what we have to do, this will be enclosed within a for loop. For here the variable that we have already introduced here. So define one variable here that for year is equal to start. Condition to be tested is year less than or equal to end, then year plus plus. Taking the condition if year mod 4 is equal to 0 and year mod 100 not equal to 0 or year mod 4 equal to 0, printf percentage d is if else percentage d is not a leap year, closing curly brace, finally return 0. In this example, we need to find only or print only the leap years. So we can skip this condition, else block, right, is omitted. If year mod 4 is 0 and year mod 100 not equal to 0 or year mod 400 is equal to 0, we can print only the year. So here I put a message printf n leap years in between or leap years in the given range or slash n. Printf slash n. Let us use horizontal tab to leave right some spaces. Printf percentage slash t percentage t. Every time, right, the message will be printed. So to avoid the right, only the year is going to be output year. That's our enter slash t percentage t year. If the condition is true, then the value is printed. Let us check the code by defining the variables aim to start, end, comma, year, save the file, F2, F9. File has been compiled successfully. Then Control F9. Enter the starting year, say 1. Enter the ending year, first I give, say 100. It prints the leap years in the given range. 4, 8, 12, etc. up to 96, right? These are multiples of 4. So clearly these are the leap years. When I give the range, Control F9, starting year 1, ending year 2500, pressing, you can scroll up and scroll down here, output window. 4, 8, 12, etc. You can find, right? First century year is 400 because 100 is not available, 200 is not available, 300 is not available. Find where the 400 is. Yeah, here 400 is there. So hereafter, right, multiples of 400 are leap years 400. Then you can find 800, 1600, like this. Finally, 2500 before that, right, to 2496. Then once once you can find a 2400. These are these are the leap years obtained in the given range. In case if you want to find a count on the number of leap years in the given interval, here for to write one variable, say count or c is equal to 0. If the condition is true, if year mod 4 is 0 and year mod 100 not equal to 0, or year mod 400 is equal to 0, then we need to execute two statements. One, count needs to be incremented by 1, and printing this message. This script should be enclosed within the block opening and closing curly braces. Then finally print the value of count. Print slash n. Count is percentage d, comma, count. Count is in the variable c. Let us check the code again. Control F9. Starting year is 1. Ending year is 2500. Means the count is 606. 606 years are there. Leap years are there in that interval. Suppose Control F9. 2401, 2403. Number of leap years in the given range are right. No leap years are there. So count is 0. Understand the flow of for loop. Here we have introduced a for loop where the variable year starts with the value start, condition to be tested is year less than or equal to n. Then year is incremented by 1. Only one for loop is introduced. Within that range, we have tested the leap years only. We have printed only the leap years in that interval. Have any doubts in this example?
No, sir.
The same example could also be written using a while loop or a do while loop. Because it depends upon the user's point of view, right? In case if you prefer to use while loop, always no problem, right? You can go with while loop. Or if you like to use a do while, same thing. It could also be converted into the equivalent do while block. Likewise, a switch statement, we can also write nest or block, place a switch statement inside another switch statement. It also forms a part of a nested switch statement. But in this example, we have introduced only one part. Our inner part, right, can be controlled through outer part. In case if you want to find out the given numbers are prime or not, that will be a good example or to illustrate the nested part looping statement. For example, I tell you the logic in this session. N, right? We need to check if n is prime or not. To check if the given n is prime, we need to find if there are any divisors for the given n over the range. What is the range? 2 to n by 2. Already we have solved this example. 2 to n by 2. Suppose take a value of j. Check if n mod j is equal to 0. If n mod j is equal to 0, n is the input integer, j ranges from 2 to n by 2. For each value of j, we are checking the condition if n mod j is equal to 0. If n mod j is equal to 0, ultimately j is the divisor of the given integer, or we can say n is divisible by j. This means n has some other factor other than 1 and itself. So n is not a prime in this case. To implement this logic, what we have to do, we can use a for loop, getting the input value of n, and we can design a for loop for j is equal to 2, j less than or equal to n by 2, j plus plus. Then the condition to be tested is if n mod j is equal to 0, we can terminate the process by telling the message that the given integer is not a prime one. So that the usage of one for or usage of simply the iterative statement for will be introduced here. The problem is if you want to check the prime numbers in the given range as we solved in this example. For example, starting year is 2000, ending year is 3000. In between that interval, finding the number of leap years. Likewise, here, if we want to find out, for example, the number of prime numbers are simply the prime numbers within that range, start comma end, what happens? We need to place another for loop. Actually, this checking if condition, this has been placed inside the for loop that comprises the range of s. For j is equal to 2, j less than or equal to n by 2, j plus plus. This is for checking one integer, which is prime or not. To check for multiple integers are in the given range, start comma end, you can assume, right, the value start to the variable j, then j will be incremented by 1 until the value j reaches a value end. So in that case, we can use another for loop. That for loop defines a range like this. For I is equal to start, I less than or equal to end, I plus plus. In the outer for, we need to use this inner for where the value of n is controlled through the variable, say outer variable I, so that the problem can be solved using two for loops. So ultimately, this is the place where we can apply nested for loop to find the solution. Have any doubts? Try to solve this exercise. If not, I solve it in the next session, right? The usage of nested for loop for finding the or counting the number of primes in the given interval. This is solved by applying the nested for loop statements. Have any doubts? If you have any doubts, now we can ask. No doubts? Okay, please go through the session. Thank you very much.
Thank you, sir.